Hey 8th graders, Mr. Humphreys here. Hopefully you're all doing well. I will tell you that this lesson is going to seem like an English lesson. We're going to talk about conditional statements. The first thing I want you to write down is this. If an animal is a horse, then it has 4 legs. This is something called an if-then statement. An if-then statement is called a conditional statement. So this entire thing is called a conditional statement. Now, the hypothesis is the part that is the if part. So right here, this is the hypothesis. And the conclusion is the part that follows the word then. And this right here is your conclusion. So let's rewrite your 3 vocab words. All right. A conditional statement is a statement that can be written in the form if P then Q. So if it's if then, you have a conditional statement. Now something else, you're going to see this. It's the same thing if you see this. Lowercase p, lowercase q. That means, and it's read as if p, then q. So you're going to see this a lot of the time, that p and then an arrow q means if p, then q. The hypothesis is the part that follows the if. The conclusion is the part that follows the then. So make sure you have those 3 vocab words written down. And let's start with our first example. Example number 1. Let's identify the hypothesis and the conclusion. So here's your conditional statement. A number is an integer if it is a natural number. Now this is going to be weird because it's an if-then statement, but notice where your if is. Your if is at the end. So if it is a natural number, is your hypothesis. So a number is a natural number, is your hypothesis. Your conclusion is that the number is an integer. Even though the word then isn't there, since the if was the second part, the conclusion, which is your then, is the first part. So always find where the word if is. So the conclusion, the number is an integer. Our next example. If a butterfly has a curved black line on its hind wing, then it is a viceroy. So we're going to use white for our hypothesis. Here's the if. So our hypothesis would be this. A butterfly has a curved black line on its hind wing. So this is the hypothesis. The then part is after, right here, so it is a viceroy. The butterfly is a viceroy is your conclusion. So in review, many sentences, as you saw with the first example, have words if and then, but many don't have the words if or then. So many sentences without the words if and then can be written as conditionals. To do so, identify the sentence's hypothesis and conclusion by figuring out which part of the statement depends on the other. So example number 2 says, write a conditional statement from each of the following. That means you have to use if and then. If it says write a conditional statement, you have to use the words if and then. So here's our first statement. The midpoint M of a segment bisects the segment. So you have to come to a conclusion of what the hypothesis is, what the conclusion is, and then write it as an if-then. So looking at this, we know that we have a midpoint M. So start thinking of it if-then. So if we have a midpoint M, then it bisects the segment. So we have to take the if M midpoint thing. So here's how we'd write it. So we're going to start there. If M is the midpoint of, that should be of, let me change it. There we go. So if M is the midpoint of a segment, what do you think the then's going to be? If M is the midpoint of the segment, then M bisects the segment. Whoops. So if M is the midpoint of a segment, then M bisects the segment. Try this one on your own. Blue jays are birds. What do you think you'd write for blue jays or birds? You'd say, if an animal is a blue jay, then it is a bird. There's your if-then statement. Now, if you think about it this way. What works with what? You couldn't have said, if something is a bird, then it is a blue jay. That's not true. Because if something is a bird, that doesn't mean it's a blue jay. So you have to think to yourself, what statement depends on the other? And then the one that makes sense is going to be your conditional statement. All right, this next part talks about another vocab word which is called the truth value. A conditional statement has a truth value of either true or false. That means every single conditional statement is going to be true or false. This is the part that's going to be weird because I'm telling you, when you see some of these, you're going to be like, that's false. But it's really going to be true. It really is going to mess with your brain. I'm not even going to lie. This is going to really kind of mess with some of your brains. But keep this part in mind right here. It is only false if the first part is true and the second part is false. And this should be the word the. So, what I would like you to do first is, the book does not have this, but this is what always helped me when I was in school. Because quite honestly, it drove me crazy because there were some things that I thought to myself, well, this has to be true. Or this has to be false, when in fact it wasn't. So make this little cheat sheet. So we're going to make a chart. Here's our lovely chart. That's a really bad line. So let me try that again. All right, so we have a P column and our Q column. And if it helps, P represents your hypothesis and your Q represents your conclusion. Then our final statement is this. If P, then Q. So here's how it works. We could have a true hypothesis and a true conclusion. We can have a true hypothesis and a false conclusion. We can have a false hypothesis and a true conclusion, or we can have both of them being false. The only time, I'm going to say this like 15 times, the only time that it is ever going to be false is if the hypothesis is true and the conclusion is false. It's really easy to recognize the true ones. It's really bizarre when you see the false ones and they're really true. So it's going to mess with your mind. I promise you it'll mess with your mind. Just think of it this way. True, false, then the whole thing is false. That's it. All right, so here we go. Example 3. Determine if each conditional is true. If false, give a counterexample. A counterexample is just proving that it's false. Our first one. If today is Sunday, then tomorrow is Monday. So you're going to look at this. We're going to start with an easy one. So it said, if today is Sunday. So when this is true, then tomorrow is Monday. Is that true? Yes. Why? Because Monday always follows Sunday. So this is a true one because true, true, and therefore it's true. So if today was Sunday, then tomorrow is Monday. Our next one. If an angle is obtuse, then it has a measure of 100 degrees. So you can draw an obtuse angle. Okay? But is it going to be 100 degrees? No. So this could be true. And this is false, though. It could be true, but it doesn't mean it has to measure 100 degrees. So since this one is false, we have to give a counterexample. So can you find a counterexample? Absolutely. You could say, if an angle is obtuse, then it could be 95 degrees, not 90. So let's try that again. It could be 95 degrees. There you go. That's your counterexample. Because it has a counterexample, it's false. Our next one. If an odd number is divisible by 2, then 8 is a perfect square. Now you're going to look at this and be like, this doesn't make any sense. I understand. So first off, an odd number is never divisible by 2. So this part is false. Then 8 is a perfect square. Well, that's also false. So we have false and false. Looking at our chart, because they're both false, the entire statement is true. The conditional is true because the hypothesis is false. If this first part is false, it's automatically true. I know it's weird. All right, D. If a dog is a whale, then today is Monday. I know you want to put false. I know that. If a dog is a whale, well, first of all, a dog is not a whale, then today is Monday. Well, today could be Monday. We don't know. But because this first one is false, if you look at your chart that you just drew, it has to be true. This statement is true. The only time it is ever not true is when you have this as B. And by the way, you can't give a counterexample. I mean, think about it. What are you going to give as a counterexample here? If a fish is a bird, then tomorrow is yesterday? I don't know. I mean, you can't give a counterexample to this because it doesn't even make sense. So I know this is confusing, but you have to remember that one statement, that chart. This is the only time when your conditional can be false, is when the hypothesis is true and the conditional, or not the conditional, the hypothesis is true and the conclusion is false. All right, your next 3 vocab words have to deal with doing something with the conditionals. So here we go. Converse, inverse, and contrapositive. I want you to go back to your original statement. I'm going to move this down. Remember that your original statement can be written as if P, then Q. The converse is when you flip the hypothesis and the conclusion. So your hypothesis would be if Q, then P. The inverse is when you take your original one and just negate it. So that means you would say if it is not something, then it is not something. So this would be how you write negating. If not P, then not Q. Then the contrapositive is when you flip that. So you would have, if you did not have Q, then not P. So let's use this as an example. So we're going to use all of this and write one conditional statement and write the converse, the inverse, and the contrapositive. All right, so here's example 4. Now I'm just going to tell you what I want you to write. This right here, that's given to you, that's your conditional statement, your if-then statement. If an insect is a butterfly, then it has 4 wings. I want you to write the converse, the inverse, and the contrapositive, and then find the truth value of each. So we're going to start with the converse. The converse is when you just flip the if and then around. So the first one is, now we're going to say if an insect has 4 wings, then it is a butterfly. We'll talk about the truth value in just a second. We're going to go to the inverse. The inverse is taking your original statement and just using the word not. So our inverse, if an insect is not a butterfly, then it does not have 4 wings. Now your contrapositive is when you take your inverse and just flip them around. So our contrapositive would state, if an insect does not have 4 wings, then it is not a butterfly. So let's go through and see which ones are true and false. Now remember, if you can find a counterexample, then it's false. So, converse. If an insect has 4 wings, then it's a butterfly. Well, that'd be false. Why? Because if an insect has 4 wings, which could be true, it doesn't have to be a butterfly. You could say false because it could be a moth, let's say. That's not a butterfly, but it has 4 wings. Inverse. If an insect is not a butterfly, then it does not have 4 wings. Well, if an insect is not a butterfly, that could be true. then it does not have four wings. Well, wait a minute. Just because it's not a butterfly doesn't mean it doesn't have four wings. For example, a moth is not a butterfly, but it does have four wings. So you can prove a counterexample. Once again, a moth has four wings. So this statement is also false. So the converse is false, the inverse is false. The contrapositive. If an insect does not have four wings, then it is not a butterfly. Since butterflies have to have four wings, so you're saying if an insect does not have four wings, then it is not a butterfly. Absolutely, that's true. Because if an insect doesn't have four wings, well then it can't be a butterfly because butterflies have four wings. So that's true. So in the example that we just did with the butterfly and the moth, the conditional statement, which is your original one, and the contrapositive are both true. And the converse and inverse are both false. Related conditional statements that have the same truth value are called, a vocab word, logically equivalent statements. So let me write that down. Logically equivalent statements are related conditional statements that have the same truth value. So for example, I'm just going to quickly write this down. We had our conditional first. Then we had our converse. Then we had our inverse. And then we had our contrapositive. Now, in our butterfly problem, the first one is true because that was your original statement. Your converse was false, your inverse was false, and your contrapositive was true. So the conditional statements that have the same truth value, for example, conditional and contrapositive, and then converse and inverse, they are logically equivalent statements. So you have to realize, though, that not all, the converse of true conditional is not necessarily false. So all four related conditionals can be true. They all can be false, depending on the statement. So this is not always true. Sometimes they'll all be true. Sometimes they'll all be false. We have quite a few vocab words in this section. The first one was conditional statement. That was your main statement. The hypothesis was the if. The conclusion was the then. Negation we really didn't talk about, but negation just means it makes it, the negation of a true statement is false and the negation of a false statement is true. All it does is it puts a not in front of it. Converse, if you remember, is exchanging the hypothesis and conclusion. The inverse is by negating the hypothesis and conclusion. And the contrapositive is basically flipping the inverse. And logically equivalent statements are related statements that have the same truth value.